everyone. I'm here once again for Mathematics Mail. It's a beautiful program that is meant for beautiful people, beautiful students and handsome students, even also for beautiful parents and handsome parents. It is a program where we use different methods, simplified methods, in ensuring that the study of mathematics is improved on a daily basis. Today on Mathematics Mail, we're going to look at plane geometry 2. We have looked at part 1 of plane geometry and we have several videos on that. So you try as much as possible to watch those videos in our YouTube channel and then also watch them on our Facebook page, and you will get to know more about plane geometry 1. That's all about lines and what? Angles. So today we are going to begin the journey on plane geometry 2. Plane geometry 2. Generally, when we want to begin any topic, we usually look at the objectives. That's the areas that we need to cover in the course of studying that particular topic. And today on plane geometry 2, the objectives are as follows. At the end of the study, the students are expected to know the following. 1. General descriptions of plane shapes. Then we look at polygons and descriptions of polygons. Then we look at calculations of angles of polygons. So that's the 3 objectives that we are going to accomplish in the course of studying plane geometry 2. All right. Before we begin, it's important that you stay away from every form of distraction. Anything that will distract you, please make sure you run away from distraction. And then get all the necessary materials that you need for effective study. Now let's begin this journey. But remember that you need to subscribe now to our YouTube channel and then also like our Facebook page at Mathematics Mail. Very, very important. All right, let's begin this wonderful journey on plane geometry 2. So first we are going to look at the general description of plane shape. So we say general description of plane shapes. All right, what are plane shapes? We know about shapes already. Yeah, we know about shapes already. Everything around us, they have shape. Even though the shape may not be uniform shape or definite shape, the shape may be composite. But even the things in your house, they have shape. The cup in your house, it has a shape. The clothes you wear, your head even, your head has shape, and so on and so forth. We deal with shape from time to time. So what exactly is a shape or a plane shape? Because our interest today is on plane what? On plane shapes. You know, when you sew cloth for students of these days, some of them will take it back to the tailor or to the seamstress for the person to also, they say, let's shape it. Yeah, let's shape it. Because everybody is looking for what? Shape. Even those that are involved in modeling, some of them, they go without food so that they will have one kind of figure or shape in order to win the beauty contest. So virtually everybody is a mathematician. If you are not a mathematician in the market, you are a mathematician as a model because you are looking for shape. But anyway, the shape we want to talk about is a plane wall shape. And generally we say that plane shapes are 2-dimensional closed figures. Plane shapes are 2-dimensional closed figures. So for it to be a shape, a plane shape, 2 things are involved. It must have 2 dimensions, and then it must be a closed a closed figure. So if I have this, it's not a plane shape. It's not a plane shape because it's not closed, it's still open. But when I do this now a plane shape. This 2-dimensional. This is a dimension and this is a dimension. Now we have shapes we call solid shape. That's a 3-dimensional shape, like you talk about a cuboid, a cube like this. Talk about a cuboid. This three-dimensional. These ones are three-dimensional shapes. We call them solid shapes. They are not plane shapes. Why are they three-dimensional? Look at 1, 2, and 3. So they are just like this. You see that? Three-dimensional. You see that? But in plane shapes, they are two-dimensional closed figures. Two-dimensional closed figures. Now, all plane shapes, they have sides. They have sides. The sides can be straight line or they can be curved. We are going to see that in the course of the study. So, plane shapes have sides or corners. They have sides or corners, like what I've drawn before. How's that? This is side, or what you call a corner, because from here it has to corner to this. So this is a corner, this is a corner, this is a corner. So sides and corners, that's in a plane shape. Sides and corners. A side in a plane shape is a straight line that forms part of the word, the plane shape. So a side in a plane shape, a side in a plane shape is a straight line that forms part of the shape. So a side in a plane shape is a part, it's a straight line that forms part of the word shape. So a side in a plane shape is a straight line that forms part of the word shape. So if I have this now, this is a side in a plane shape and it forms part of the word of the shape. It forms part of the shape. Alright. So we have known the meaning of plane shapes, and we have said also that plane shapes, they have sides, or what we may refer to as what? Corners. And we say that a side in a plane shape is a straight line that forms part of the word of the shape. A straight line that forms part of the shape is a side in a plane word, in a plane shape. Now, all plane shapes are polygons except a circle. All plane shapes are what? Are polygons except what? A circle. A circle is the only plane shape that is not what? A polygon. So let's put it down. All plane shapes are polygons except a circle. So a plane shape consists of polygons and what? Circles. So a circle, polygon. So all plane shapes are polygons except what? Except a circle. The only plane shape that is not a polygon is what? A circle. So polygons consist of plane shapes consist of polygons and what? And a circle. Yes. So if you are asked to name a plane shape or to give examples of plane shape, it's just circle and polygons. Now inside polygons we have so many plane shapes that we need to do what? Describe inside our polygons. Now polygons can also be complex. They can be composite. You can have a combination of many plane shapes, yes, to form a single plane shape. Like you can have this now. You can have something like this. This plane shape is not uniform. You see that? It's not an uniform plane shape because it has so many shapes joined together. Here we have a triangle, a sort of. Now here we have a sort of semicircle. So this one is composite. It's composite. We are going to look at this more when we now begin to look at mensuration. In mensuration, we talk about areas and perimeters of shapes. But we are looking at geometry where we deal with lines and what? angles. So our interest in geometry is to calculate angles on lines and angles in what? In shapes. Angles on lines and angles in shape. Remember, we still have part 3 of this plane shape, of plane geometry. And in that part 3 of plane geometry, we'll be looking at circle geometry, where we'll be looking at angles in a circle. Yes, angles in a circle. There are so many theories. What we refer to as circle theory. We say that angle subtended at the circumference of a circle is twice angle at the circumference is angle at the center, and so on and so forth. We are going to see that in plane geometry, part 3 of it. All right. So all plane shapes are what? Polygons, with the exception of what? Of circles. Circles are not polygons. A circle is the only plane shape with what? With curved parts. With curved parts or curved corners. So a circle is the only plane shape that has a round part or a round what? A round corner. We are going to see that by the time we now begin to look at what? Circles. So far we have been able to know a little about what? About plane shapes. Now, plane shapes can be in different forms. That's the polygons now, because we say we are going to look at circles later. So that's why we have to look at the second objective. We have established that all plane shapes are what? Polygons. And what? Circle. You see that all plane shapes are polygons, with the exception of what? Of a circle. So when you want to mention plane shapes, you talk about polygons and what? And a circle. So a circle is the only plane shape that is not what? A polygon. So a circle is a plane shape. Polygons are also plane shapes. So it's inside polygons that we have all other plane shapes. Quadrilateral, pentagon, triangle, hexagon, decagon, decagon, and so on and so forth. All of them are inside what? Polygons. They're inside polygons. And that's why the second objective, we want to look at polygons and their what? Description. So we move to the second objective, polygons and descriptions of polygons. And description of polygons. What's a polygon? A polygon is a plane shape bounded by straight line. Polygons are plane shapes bounded by straight what? Straight line. By straight line. Any plane shape that is bounded by straight line. By straight line. That plane shape is known as what? A polygon. That's why a circle is not a polygon, because a circle has a curved part or a round part. So it's not bounded by what? By straight line. That's why a circle is not what? A polygon. So a polygon is a plane shape bounded by what? By straight lines. Now, polygons are usually named based on their number of what? Sides. So we name polygons. We name polygons based or depending on their number of what? Sides. So the name given to any polygon is dependent on the number of sides present in that word polygon. So we are going to put up a table that will give us names of some polygons and few other things that we need to know about polygons, because we are talking about general descriptions of what? Of polygons, the description of polygons. So we have to look at a table that will consist of polygons and few other things that are necessary that we know about polygons. Okay, let's look at that. The table below gives the names of polygons and other properties let's look at the table. I believe you have taken down the objective, so we need to clear that. Okay, let's look at. We are going to be conservative, so let's say the polygons. Okay, let me put it this way: number of sides of the polygon. Okay, number of triangles, number of right angles, then let me also add sum of interior angles. Okay, the simplest polygon is the polygon we call a triangle. And a triangle has 3 sides. We're coming to this. Followed by what we call quadrilateral. Just for space, let's aggregate. Quadrilateral. The quadrilateral has 4 sides. We have another polygon we call a pentagon. The pentagon has 5 sides. We have another one we call a hexagon. It has 6 sides. We have another one we call a heptagon. A heptagon has 7 sides. We have another one we call octagon. Octagon has 8 sides. We have another one we call nonagon. Nonagon has 9 sides. And finally, where we're going to stop, there are so many others. We have what we call a decagon. The decagon has 10 sides. Now, in a triangle, how many triangles are in a triangle? Just one. One triangle. In a quadrilateral, how many triangles are in a quadrilateral? 2. In a pentagon, how many triangles are there? Just 3. In a hexagon, we have 4 triangles. In a heptagon, we have 5. In octagon, we have 6. In nonagon, we have 7. And in decagon, we have what? 8. We have 8. Oh, beautiful. We have 8. Somebody will say, what is it? Don't worry. You will see how we arrive at this later. Yeah, in the course of studying this beautiful topic, you will see it's not a magic. Mathematics is not magic. It's not magic. It's rational. It's very logical. It's not magic. It's real. So real. Some people think it's too abstract. No. There are various applications of mathematics available everywhere. Okay, let's come back to this. Now let's look at this one now. The number of right angles. Now you know that a right angle is 90 degrees. So we have 2 right angles here. We have 4 here. We have 6 here. We have 8 here. We have 10 here. We have 12 here. We have 14 here. And we have 16 right angles here. Somebody is still thinking, how are we arriving at all this? Don't worry. You will soon know how we arrive at all this. So what is the sum of the interior angles? The interior angles are angles that are found inside a figure. That's the interior angle. So what the sum of interior angles in a triangle will give us 180 80 degrees. Sum of interior angles in a quadrilateral four-sided polygon is going to give us 360 degrees. Sum of interior angles in a pentagon will give us 540 degrees. Sum of interior angles in as in a hexagon now will give us 720 degrees. Sum of interior angles in a heptagon will give us 900 degrees. Now, sum of interior angles in an octagon will give us 1080 degrees. Now, sum of interior angles in a nonagon will give us 1260 degrees. And sum of interior angles in a decagon will give us 1440 degrees. Oh, beautiful. It's beautiful. Beautiful. So that's the table that shows us the names of the polygons, the number of sides, and other properties. So we have just one triangle in a triangle. A triangle has 3 sides. A quadrilateral has 4 sides. The word lateral is side. Quad means 4. So quadrilateral, 4 sides. Pentagon. You know, this pent, hex. When you do organic chemistry also, you come across pentane. That's an alkane that has 5 carbon. Hexane, an alkane that has 6 carbon. So this pent and so on and so forth, they are just telling us the number of what? Of sides. So these properties are important. We are still going to, when we begin to look at the third objective, that's calculation of angles in a polygon, we are going to see how we arrive at this, because before we start the calculation proper, we are going to look at various points that will help us in the world, in the calculation. All right, that's enough for now. We are going to go on a short break, and when we return, we are going to continue with plane geometry too. And the aspect we'll be going over to is on calculations of angles in shapes, particularly in plane shapes, particularly also in what you call polygons, angles in a polygon. That's what we're going to focus our attention when we return. Please make sure that you subscribe to our YouTube channel and continue to enjoy our meal in Mathematics Meal. Remember, a meal a day is enough to drive away mathematical foolishness for that particular day. If you want to look more attractive in life, become a mathematician. Mathematics will make you smart and also make you very attractive. Just like myself. Am I not attractive? You cannot deny that. Don't mind me. We shall be back to continue with plane geometry. God bless you.